Hey kids, Flexing Teacher Weber here. I hope you're having a good day. Just wanted to do a couple videos here to review the concepts we did today in dividing of fractions. I called this Making the Connections because we're taking everything we've learned with dividing fractions and hopefully coming up with some big ideas here. So what this first question involves, it involves exactly how we started out with dividing fractions. We started out with a whole number divided by a fraction. And we ask ourselves, how many 3/4 fit inside of 4? So we use 4 rectangles to represent 4 holes. And we want to count how many 3/4 are in 4. So we divide them into 4 equal parts each. And then we shade in three out of 4. And then we count how many groups of 3/4 are in 4 holes. Well, I count 1 group of 3, 2, 3, 4. Oh, look at that. I forgot to divide my last rectangle there. So there's 5. And then there's 1 left over. So 1, 2, 3, 4, 5 groups of 3. That's where I get my 5. And then there's 1 left over out of what should have been a group of 3. So 5 1/3. Now the other thing we did is we recognized that we could just do 4 times 4. So we could do 4 times 4 equals 16. So do the whole number times the denominator, and then divide that by 3. And 3 goes into 16 5 times, remainder 1 out of 3. And we get the same answer. So I want to explore this more right here, this thing that we did right here. Okay? So I'm going to flip forward. And I've put here that multiplication is the opposite of division. So if we take this question, 4 divided by 3/4. Now, when we're dividing fractions, we're also doing some multiplying, right? We're doing the 4 times 4. So what we actually did here is we can write the question like this. We did 4 times 4 divided by 3. So why not write it like this? 4/1 times, flip the last fraction to 4/3. And then what you get is you get 4 times 4 is 16, and 1 times 3 is 3. And 3 goes into 16 5 times, remainder 1 out of 3. Now I call this method, this isn't the official math term, but I call it keep the first fraction the same, change the multiply, the divide to multiply, and flip 3/4 to 4/3. That's called multiplying by the reciprocal. I call it keep, change, flip, or better yet, Kentucky chicken fried. So that's the idea we're going to explore today of multiplying by the reciprocal. Okay. Now we also did things like this. 7/8 divide by 3/4. And I want to know how many 3/4 are in 7/8. Well, in order to show that on the same rectangle, I have to have a common denominator for 8 and 4. The common denominator for 8 and 4 is 8. Now 7/8 stays the same, but 3/4 will become 6/8. When I multiply the denominator and the numerator by 2, I'll get 6/8. So that's how many 6/8 are in 7/8. Well, I'm going to put 7/8 onto this whole fraction, this whole rectangle. I'll divide it into quarters, and then I'll divide it into eighths. And I will shade in 7/8. 1, 2, 3, 4, 5, 6, 7. And now I will count how many 6/8 are in 7/8. I'll count one group of 6. That's the whole number 1. 1 left over out of what should have been a group of 6. So the answer to 7/8 divided by 3/4 is 1 1/6. Now look at this. Remember when we had the common denominator? We could just do 7, first numerator, 7, divide by second numerator, 6. And 6 goes into 7 one time, remainder 1 out of 6. And we get the matchy-matchy. Now, we can also explore this idea with the keep, change, flip idea. So if I have 7/8, divide by 3/4, I can solve this by keep, change, flip. Keep the first fraction the same, change, divide, the multiply, flip 3/4 to 4/3. You can also call that Kentucky chicken fried. So 7/8, keep, change, divide to multiply, flip 3/4 to 4/3. Now the good thing about this is that you can simplify your diagonals. 4 into 4 goes once, 4 into 8 goes twice, and you're left with 7 times 1 is 7, 2 times 3 is 6, 6 goes into 7 one time, remainder 1 out of 6. So keep, change, flip is a strategy that will work every time, and you don't have to do any common denominators or diagram drawing. Now in my next video, we're going to explore this idea of multiply by the reciprocal or keep, change, flip in more detail. That's all for now. Flexing Teacher Weber out. Hey kids, Flexing Teacher Weber here with part 2 of the dividing fractions by multiplying by the reciprocal video. In this video, we're going to look at more of the idea of what the reciprocal is. So since multiplication is the opposite of division, we can divide fractions by multiplying by the opposite of the first fraction. So the opposite of the fraction is called the reciprocal. So let's take a look at how we'd write the reciprocal of a few fractions. So we're going to state the reciprocal of each fraction. So if I have the fraction 4/5, the reciprocal of that fraction, which I'll just call r, is the flip 5/4. And then you might even go ahead and write that as a mixed number, 1 and 1/4. Now if I have the fraction 1/3, the reciprocal of that fraction, which I'll call r, is 3/1, and I might write that as just 3. Okay, if I had the fraction 3/10, the reciprocal of that fraction would be 10/3. And I might write that, 3 goes into 10 3 times, remainder 1 out of 3. The reciprocal of 8, well, 8 is 8/1, so the reciprocal would be 1/8. Just the flip. Now, when you're dealing with things like mixed numbers, you'll want to change it to an improper fraction first. 5 times 4 is 20, plus the 4 is 24/5. So the reciprocal would be the flip of that, 5/24. Same thing with 6 1/8. 6 1/8, you'd want to change it to an improper fraction first. So that's equal to 8 times 6 is 48, plus 1 is 49/8. And then the flip of that, or the reciprocal, is 8/49. Okay, so that's how you write the reciprocal of different fractions. Now let's use that idea to divide some fractions. So we're going to divide each of these by multiplying by the reciprocal. So, number 1, you have the fraction 5 divided by 1/4, which we can, if we do multiply by the reciprocal, which is the same as keep, change, flip or Kentucky chicken fried. We would keep the first fraction the same, but I would write that 5 as 5 over 1. I would change divide to multiply, and I would flip 1 over 4 to 4 over 1. Multiply your numerators and denominators. 5 times 4 is 20. 1 times 1 is 1. And that equals 20. Okay. Number 2, 8 over 10. Divide by 2 over 5. I'll do keep, change, flip, Kentucky chicken fried, so 8 over 10 times 5 over 2. And at this point, you can simplify. I've got 5 and a 10 there. 5 divided by 5 is 1. 10 divided by 5 is 2. Over here, I've got an 8 and a 2. 2 divided by 2, 1. 8 divided by 4 is 2. Pardon me, that should have been 8 divided by 2 is 4. I'll just rewind that. So let's go back and do that again so we don't get confused. So my diagonal number is 8 and 2. I'll do 2 divided by 2 is 1, and 8 divided by 2 is 4. Now this leaves me with 4 times 1 is 4, and 2 times 1 is 2, and 4 divided by 2 is 2. Now something interesting here, don't forget the common denominator method. The common denominator of 10 and 5 is 10. So if I wrote both fractions with the denominator 10, 5 times 2 is 10, 2 times 2 is 4. And the common denominator method would say take the first numerator, which is 8, and divide by the second numerator, so 8 from here, and divide by the second numerator 4. And you would get that that equals 2, which is exactly the same as you get down here using keep, change, flip. Okay. Number 3, 5 over 12. Divide by 3 over 4. Keep, change, flip. 5 over 12 times 4 over 3. Simplify the diagonal numbers. I'll simplify my 4 and my 12. 4 divided by 4, 1. 12 divided by 4, 3. So I do 5 times 1 and 3 times 3, and that's 5 over 9. Now check this out. If I did the common denominator method, the common denominator of 12 and 4 is 4. Is 12. So if I wrote both fractions with denominator 12, I'd do times 3, and I'd get 9 over 12. And check this out. Common denominator says if I have the same denominator, I just do 5 divided by 9. And 5 divided by 9 equals that. So sometimes the common denominator method works. If we can easily get a common denominator, multiplying by the reciprocal always works, especially when you have large numbers, like in this last example. 21 over 25, divide by 7 over 15. I'm going to do keep, change, flip. And the good thing about keep, change, flip is now I can simplify and get smaller numbers. 15 and 25. 15 divided by 5 is 3. 25 divided by 5 is 5. 21 and 7. 7 divided by 7 is 1. 21 divided by 7 is 3. We're left with 3 times 3 is 9, and 5 times 1 is 5. 5 goes into 9 one time, remainder 4 out of 5. So now we have a whole bunch of methods to divide fractions. Multiply by the reciprocal works all the time. Common denominator method is good if you have fractions that easily have a common denominator. And the diagrams just sort of show us where all this stuff comes from. So I hope that helps with your assignment titled Pictures and Diagram. That's all for now. Flexing Teacher Weber, out.